Thank you. All right. So kicking off, once again, good afternoon, welcome. My name is Chizurum Egwunwankwo, and I should first apologize. We were supposed to have the session last week, Friday. But Taofeeq had one or two things come up and we couldn't hold it last Friday. So if you're still here, even after we postponed, thank you so much for making time to be here. So a little bit of, or just get to know your host, if I'm to put it that way. So we are Interswitch developer community. As you know, Interswitch is a financial technology company, and then the developer community is umbrella, to use that word. It's under Interswitch and is owned by Interswitch group of companies. That's the first. So speaking of why we exist or who we are, I've already shared that we are a developer community established by Interswitch, a financial technology company. And one of the reasons why we exist is to provide support for developers that are building or using our APIs. So whether you want to meet other builders like you want to speak to our support team, should you run into integration issues, or you have questions about our APIs, integration and whatnot, or even our developer tools, you can get all of that support in and through our community. Then the third is also for the professional development of developers beyond Interswitch, right? So whether this is through events like the workshop that we're having now, through mentorship and a hackathon, which I'll speak more towards at the end of this event, we're also go for that. Then the fourth thing is also this is similar, that of professional development, but this time for students in Nigerian campuses. So think of it this way: we're established by Interswitch, and our job is twofold, right? The first is to provide support for anybody that is building with our APIs or even curious about how our APIs work and use cases for our APIs. And secondly, to support the professional development of developers at different levels in Nigeria. So that's it. And something small that I wanted to do today is just introduce you to a service that Interswitch has that you've probably not heard about, and that is our API marketplace. So I know that people probably know Interswitch, or you know that we have a payment gateway, you know that we have APIs, for payments and all of that, but not a lot of people know that we have an API place. So it's a new service that Interswitch, launched, and the purpose is to make it easier for developers to find and use APIs from a central place. So if you need an API for this use case and another API for that use case, you don't have to go to different providers, go through all the KYC process, all the integration and all of the time and energy that takes. Now, if you need those APIs, be it different APIs for different reasons or different APIs that you're integrating for one app or one solution, you can find all of that in our API marketplace. So right now, this is a screenshot of some, not all, of the APIs that we have. Some of them are from Interswitch and some of them are outside Interswitch. And some of them, or in groups, is you can get payment APIs from us. You can get values added services APIs from us, and then identity verification. So different use cases. If you're looking to, get an API for physical address verification, BVA, the rest of them are payment gateway, card transactions, card payments, loans, and all of that, you can get it from the marketplace. And then one advantage of this is that we also have a community, or if you're using APIs from the marketplace, you can also get support from our community should you need it at any time. Then another advantage of this, beyond making discovery and integration easier, is that you also get like automated API key generations from the marketplace. So this is all about it for now. At the end of it, after Taofeeq's session, I'm going to come back and I'm going to take questions that you have beyond Taofeeq's session. So if you have a question on the API marketplace, how to get started, or how to join the community, or about the hackathon, which I'll share more about at the end of the session, and we can have that once Taofeeq is done. So I'm going to pause here and I'm going to hand the virtual mic to Taofeeq to begin so that we don't waste a lot of time. So this is quite practical. So if possible, you can pull out your laptop, you can follow along. It's a workshop, of course, so he's not just going to talk. He's going to take us through the practical use cases or application of the subject hand or the topic for today. So it would be great for you to also try some things alongside Taofeeq while he's showing or taking us through it. So I'm going to pause once again and then I'm handing it over to you, Taofeeq. But before then, I have very few fun facts to share about Taofeeq. So, of course, I started with the fact that he's a badass software engineer at Mastra. So, if I say badass, take my word for it. And the second thing about Taufik is that he loves anime. I mean, Taufik does not post any other thing on WhatsApp except anime. And I had to ask somebody who is super duper close to Taufik to say, hey, what's Taufik's best anime series or anime movie? I don't know if animes are movies or cartoons or I don't know. But, anyways, his favorite is Attack on Titan, and then the second is Full Metal Alchemist Brotherhood, whatever that means. But this is just to let you know that Taofik is a full-time anime lover. And then if you missed the part that he's an anime lover, I'm stressing it again by telling you that this is literally the only thing that he posts on his WhatsApp status. He doesn't post birthdays, he doesn't post his vacations, he doesn't post any other thing on WhatsApp. He just wants all of us that are seeing his status on WhatsApp to know how much love he has for anime. And then the fourth thing about him is Taofik, when he's not sharing, things about anime, maybe I think graphics from it or a screen or a recording or a video or all of that. He's also sharing really funny things. But this time, instead of the usual meme, his memes are more neat. He's sharing memes that are very sarcastic things that people write about software engineering on Twitter, and I find it very, 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 very hilarious. So this is just to let you know a little bit about him. So if you're an anime lover like Taufik, extra reason for you to connect with him after this session. So I'm just going to pause here and I'm going to hand it over to Taufik. Tao, I hope I didn't expose you too much. So you're off next.
Thank you so much. I did not expect that. Yeah, I mean, that's a perfect description of me, really, that Chizurum just gave. And I mean, as she mentioned, I'm a software engineer at Mastra. I've been working with Mastra for almost 3 years now. I think 2024 till now. It has been fun, really. And also the other things I do when I'm not really working at anime related stuff, right? I watch anime a lot, I post anime, things like that. I mean, anime is like just it's it's like the perfect art form. There's no limits to what can be achieved. That's why I love it. Um, yeah. As I mentioned, software engineer at Mastra, I started with, I'll just give a brief introduction of myself, right? I didn't study computer science in school. So a lot of the things that I'm going to talk about now, it's not like I learned it in a class or something. There are things that I taught myself and then like while building, I was trying to see, I saw, oh, okay, this is what this thing I'm trying to learn now is about. Because for a lot of people like myself that didn't study computer science in school, we don't really learn those basic foundation stuff when we're starting, right? We just go straight into practical. We find like a book or a tutorial or a video on how to build websites with HTML, and it's just straight up practical, right? We are learning with building projects and building projects. And we get good at building projects. A lot of times we get too good at building projects, but we don't really know a lot of them, the foundational stuff, right? Like data structures and algorithms become really difficult, then we have to go back to learn it. And that's exactly how it was for me. I had to go back to properly learn that. It was kind of easy for me to learn it too because I understood a lot of things easily because I've been building projects right before I went back to learn it. So I'm like, oh, okay, this thing that I did this way, I could have done it this way, right? And it just makes it really nice. There are probably some people here that studied computer science in school in uni and you've probably like gone deep into data structures and algorithms already. Like you probably did it in uni. Maybe you didn't take it too serious, but most likely you'd have watched through it a little in uni. Um, so I'm self-taught mainly, taught myself software engineering, front-end engineering mostly. Then I worked as a front-end engineer at different companies, and now I'm doing full stack at Mastra. And Mastra is it's an AI company. I don't know if there's anyone here that knows of Mastra, but it's an AI company. We build an agentic AI framework. So with Mastra, you can do the things like you can build an agent easily. We also have Mastra code, which is kind of like cloud code. So it's pretty cool to be honest. Think that's enough about me. I'll now be going into what we want to talk about today, right? Which is data structures and algorithm. I'm going to share my screen. Yes. Okay. I think it's sharing my screen now. Can everyone see my screen?
Yes, we can.
Okay, cool. Okay, so I'm going to share my screen now. So I didn't plan on creating slides before, but I figured okay, it's probably easier to create one and follow the slide, makes it easier to walk through the whole thing, right? Data structure and algorithm, that's like the main thing. And a lot of us that are looking for job, like when you are trying to get a job, especially if you are trying to get jobs at some particular kind of companies or a foreign job, you have to know data structures and algorithms because that's what they do a lot, right? They use that to weed out a lot of people. Just, oh, it's coding challenge, and then they give you a crazy algorithm to solve to, and you have to not just solve it, you have to show them that you understand what you're doing. You didn't just cram, you didn't just like memorize these things, you understand what you're doing, you understand the implication of the things you're doing, you can find a way to make it better. And that's the whole idea behind it. And I'm sure for me, like there have been cases where because I didn't really know the algorithm that was I couldn't really solve it, and then you just bump the interview. It happens a lot, right? It's not the end of the world. It doesn't really mean you are good. It's just okay, just a new lesson, right? You can go back, find that question somewhere else, and try and solve it again. Find a way to solve it better and things like that. And it's not just about solving the question too. There are times when you can solve the question, but still not well enough for them because you didn't explain it, or they ask you to see if you could make it better and you can't really make it better, right? While the interviewer knows, oh, there is a much better or simpler way to do this, things like that, right? And there's also the case where you know it, but at that moment, for some reason, your head is just blank, right? That happens a lot. I have friends that it has happened to where I know, oh, this guy should be able to do this, but for some reason he was not able to do it, and his mind was blank, which made him fail the interview process. And there have also been cases where you actually do well and you solve everything perfectly, but still you don't get the job. That's happened to me too before, right? Still you don't get the job because at the end of the day, it's beyond just that. But this is what we can work on, try and improve on, right? The data structure and algorithm part. And why do people struggle with it? These are the means that people struggle with it, right? A lot of times you just like that's why I mentioned earlier, I mentioned just memorizing it, like you've crammed this whole solution because you've seen it multiple times on LeetCode or something, and you've seen the solution, then you memorize the whole solution, you know it in your head, and easily you can write it down when you're asked again, right? But interviewers can easily fish out cases like that, especially when they ask you to make it better or try and do it in a different way or try and explain what you did, and then you can't really explain. Then they'll know, okay, this person probably just writing the stuff out, right? Then the big O mastery, right? Can you analyze your code, explain the complexity, like, okay, is it going to take a lot of time? Will it scale properly, right? And that's where it really comes in. Because at the end of the day, when you're joining a company, you're not just joining there to build simple solutions, right? The essence of the company is to make money, right? They are building a product which they expect a lot of people to use. And whatever you're building for them, it has to be able to work very fine when lots of people are trying to use it at the same time. So whatever you're doing, it has to scale, right? That's the main thing. Then if you're just practicing at random on LeetCode without proper structure, like you don't create a proper learning path and you're just practicing at random, um, you might feel like, okay, it seems I'm not really getting what I'm doing. Oh, I've solved like 50 LeetCode questions already, LeetCode challenges already, but still I'm not there. I don't feel like I can face it, or oh, still I get to an interview and my head is just blank because you are not properly learning. You don't have like a structured learning part. You're just doing it at random, right? Which can cause a problem. Then skipping the fundamentals, right? You're just we are rushing through like those big names. People talk about trees and dynamic programming and things like that, and you are worried about those super big names. But most times, most interview questions are relating to arrays and hash tables, right? Hash maps, as said, arrays, playing with an array and things like that. Most interview questions are relating to that because one, they don't want you to take forever trying to build something. You're not trying to, except if you are trying to join like a super crazy company, right? Or I don't know much about blockchain, but if you're going into blockchain, I believe they do a lot of data structures and like trees and things related stuff in blockchain. Except you are going into that. And even if you are going into that, you still have to start with the basics, right? Understand those simple parts first. Most are part of the simple parts, to be honest. Most interviews, they won't give you a super crazy one. They'll give you something that you can solve with like hash tables and arrays, sliding windows and things like that. Then the communication gap, how you think, explaining how you think while you're solving it is very important, right? Being able to explain why you're doing what you're doing, not just writing it down, which will show like pattern blindness if you're just writing it down without explaining. Right. So for today, we'll be looking at this, right? The foundation. We talk about big O notation, arrays and hash tables, how they work, and we'll try and solve a few questions, like a few coding challenges. 2 pointers, which is mainly trying to solve from two different positions, probably from the front and the back. And then instead of your normal loop from the beginning, this time you are going from front and back and trying to converge at the center sort of thing, right? Then you have the sliding window, which kind of like what it sounds like, sliding window. You have a window that slides, right? The aim is you are trying to fit something in that window, right? The window might be like fixed size, or the size might vary. Maybe you're trying to fit something in the window, but you don't have a fixed size for that thing. You're trying to find the perfect size, or you have a fixed size already and you're trying to find the highest number of things that can fit in that fixed size, something like that. Those are the things that we'll really be talking about today. So let's start with the big O notation, right? The popular big O notation. Everyone talks about the big O notation, and the most common ones really are O1, ON, and ON squared, right? O1 is like constant, where no matter what, no matter the amount of items that you are working with, the speed remains the same. The time or like the space it takes remains the same. For example, hash map look, which is mentioned there, which is like, for example, you are trying to check the balance on the app, right? It doesn't matter the number of people like that. If it is done properly, all you need is like the ID, right? Or for example, you have a contact list of people in your contact, like 500 people or whatever, right? But you know the exact name of who you're looking for. You're not just trying to scroll through or find the name. You know the exact name that you saved it as. For example, I am Taofeeq Oluderu. You save my contact as Taofeeq Oluderu. You know the exact name you saved it as. You just have to type in Taofeeq Oluderu and you see that contact immediately, right? So it's like you know the exact ID and you're just picking it up straight up. And that makes hashmap really cool, because you can use that to achieve it a lot. I'm going to explain what hashmap is better very soon. Then we have the logarithmic one, like log of n, like binary search. So for example, you want to search for a word in the dictionary, right? You want to search for potato in the dictionary. You open your dictionary, you just open to a random page. Then you see what is the letter on that particular page. If it's a letter before P, you know you are moving forward. If it's a letter after P, you know you are moving backward. That basically how it works. Like I don't know if anyone here uses TikTok a lot, or like checks online games. There's a game that is currently trending where you're like, okay, two people are playing, you pick two different numbers, like when two different numbers between 1 and 100, I could pick 60 and the other person picks like 25. And the person wants to guess, and the person starts with 50, which is smart. You start with 50, you're already halving the number of numbers into. Then I say, oh, it's above 50. Then you know, okay, you're going to between 50 and 100. Next thing, you have that same number into again, you say 75. Oh, it's below 75, right? Now you know you have 25 numbers to work with. Then you have that into again, right? And you could say maybe 63 or something. And I say, oh, it's below that. Then you know what to work with. And that way you are approaching the correct answer much faster, because when you have it can either be above or below, and you know where to move to, if you are moving towards the front or you are moving backwards. Then the linear chart, where it just depends on like a simple for loop, right? Just the higher the number is, the more time it will take, or the more space it will take. That's just it. Like scrolling to your WhatsApp chat. If you have a lot of chat, to take time to scroll to the top, right? And if you don't have a lot, it won't take time. So it just depends on how large the data you're working with is. Then the linear arithmetic, like n log of n, sorting a deck of cards with a match sort. And at this point, things are getting crazy, right? You are sorting it and then you're merging. Like, if you play card games a lot, when they are sorting it, it's just crazy like that. Right? That part is getting crazy. Then we have the n squared, well, nested loops. So there are cases when you have to nest a loop. Like you are looping it, and then you have another loop inside the loop. That's nested loop. And most times with most nested loops, you can find a way to cut it down to a linear to the linear notation, right? Using hash map. And we are going to talk about that very soon. And then we have the exponential 2 of n, choosing combos of turbines, like and like where you have multiple combinations that you can put together to achieve what you want to achieve. And at that point too, it's getting very crazy. So the common big rules have the drop constants. What I mean by drop constants is this, right? Like imagine for this first scenario, look at the O2N to ON, right? Imagine you're going through like a WhatsApp group with like thousands of messages, and imagine you have to scroll twice, like that's because you can't find what you're looking for easily, and you have to scroll it twice. That's a lot of scrolls that is going through, right? And compare that to someone that's going through 2 billion chats because the group is much larger. At the end of the day, it doesn't really matter. It's a lot, right? So the number or the constant at that point doesn't matter. It's still a lot. Either it's 2 billion or 1,000, it's still a lot. So instead of thinking about 2n, 3n, 4n, just O of n. When you are trying to explain a scenario like that, you just say O of n straight up, right? And well, if there's a case where no matter the number of items, no matter the data, the number of operations or the time it will take you is constant. That's when we say O of 1. Because it doesn't matter if it's like 500 items or 1,000 items. If it takes you the same amount of time to go through it, then it's constant. That's O of 1. As I say, drop the constants, right? And just work with that. Then drop non-dominant terms, right? So for cases where, for example, you're at a party, right? And you have to shake and like there are like 1,000 people at the party and they all have to shake hands with each other, right? Each person has to shake hands with someone else like that. They all have to shake hands. That's like a lot of handshaking, and that's like n square because like there's this crazy looping that's going on, right? And now imagine if 1 second, please. And now imagine if those same people, those same 1,000 people have to, each of them just have to get a drink, right? Each of them have to get a drink. That's just 1,000 trips because it's just one person per drink, right? And it's 1,000 people. That's just 1,000 trips. And you're now trying to do something that involves both of them. The handshake between 1,000 people, which will lead to like 1 billion handshakes because it's a square of that. And then just 1,000 people picking drinks is just 1,000. 1 million is like much larger than 1,000. So it doesn't really matter. That small part of it does not really matter. At the end of the day, the main thing is the n squared. That's the main operation that's occurring there, right? And when you're trying to explain that kind of solution or something, you just say O of n squared. There's no need to worry about the small part of it because the large part is so dominant that it shadows it, overshadows it basically. Then different inputs, right? Equals to different variables. What that is just saying is where A and I is saying O of A plus B is not the same thing as O of n squared. Don't assume they have the same input. And where this comes in is, for example, you're working with two lists of items, right? And you have to loop through both of them. And now, non-nested loop, where you're looping through both of them, one after the other. So it's basically the speed of A plus the speed of B. It's not the same thing as n squared. That's why it says, not to mix it up. They are two different things, right? And then the last one is the space counts too. That's like in a few things I've mentioned since I mentioned time and space, because what you're doing might take a lot of space and not take a lot of time, or what you're doing takes very little space and a lot of time. So you have to know how to differentiate the two. For example, hash map often takes a lot of space, depending, and hash map space is linear, right? Because it relates to the number of items. So let me explain what hash map means. Hash map is basically like a key value pair in coding, right? So it's kind of almost like your object, which is like you have your key. Let me just say, in your object, you have something like a apple. This is like an example of that. Uh, your object looks something like this, right? You have your key value pair, your key value pair. an hash map is something like this too, but in hash map, the way you write your hash map is like this. And this is much easier to use, to be honest. Like, and one other thing is, yeah, it's often much easier to use because for your hash map, your key can be almost anything. It could be a number, it could be an index, it could be a letter, whatever, right? And with that, and your value too can be whatever, too. Like you can easily update it, you can easily get, you can easily search, and things like that. You can also confirm if something exists or not very easily. And the sweet thing about hash map is for all of those different operations, it's always O of one because it takes the same time. Because you have the exact ID. It's like when if for this now, if I say food just set A is apple, every time I want food to get A, it's going to give me apple. And it doesn't take time to give me apple at all. Unlike if I had like an array of foods and I say apple, banana, blah, blah, blah. For this, if I want to get a particular one, I have to know the index. The only way I can get it really fast is, let's say I want to get date, right? And the index of date is 3. So I'd say foods array. What am I doing? Yeah. Foods array 3. And this way, it gets that particular one. This is O of 1, too. This is also O of 1. Same way this is O of 1, because each of them, it doesn't take time. It's not going to try and look through any list of items. It knows the exact place to go to. It just goes to that place and picks it up, right? And that's what makes it O of 1 and makes it really cool. Let's say so 15 patterns that solve like most of interview problems, right? Today we'll be focusing on hash map, two pointers, and sliding windows because like they're the simplest parts really, and they're the most basic parts. The parts that if you understand them properly, it makes it easy to go to solve a lot of them, a lot of interview and like coding challenges in the first stage. You'll be able to solve a lot with just these three. And then you can also move on to learn the other ones because you understand the basic parts already. Then we have the search and sort, like the binary search, which is the one I mentioned earlier, right? Where you can split it in two and move left or right. The prefix sum, margin intervals, trees and graphs, and things are already getting advanced already in trees and graphs. So now, before you now go down to the advanced one, dynamic programming, backtracking, grading union find and things. I'll be honest, I don't really go into those crazy ones like that because most times I don't care about them, right? Because most things that you see in the world, you can solve with the first three that I mentioned. Now let's go into arrays and hash tables. And when I say hash tables, what I mean is hash map and like hash set. I've mentioned hash map earlier, right? It's just a data structure that stores key value pairs. That's what it is. Just like the phone contact list I mentioned earlier, where you have the key, which is the name, and the value is the phone number. And like even if you have multiple phone numbers, if you use Google Contacts, right, you know that you can save multiple phone numbers on one particular name. So it's still key value pair at the end of the day. And you just, if you know the right name, you enter the name, it gives you the values immediately. Makes life much easier. That's what hash map is like. Right? Hash set is just keys, right? Not key value pair, just the keys. Like you can use it to find if there are cases where you just want to see if that value exists, or you just want to confirm if some type of value exists. You don't care about its index or maybe the number of times it exists, things like that. You can use set for that. But where you now have to know, oh, how many times does it exist or what's the index, then you have to use map because you have to store a particular thing relating to that value, right? And that's how to really determine when you want, how to determine which one to use most times. And let me just show you more in an example. I'm going to try and do this example. Let me skip this first. This to some example, right? You have a list of numbers, an array of numbers, and you want to see the index of what two numbers you can add together to get a target. So let me clear this. And let's say this is a array and our target is 9, right? Let me just this a little. Yeah. And our target is 9. Now we want to, you get this kind of question and it tell you, okay, find what two indexes, right? Will you have to get that target? We want to do two sum. I'm using cursor, that's why it's suggesting a lot of things, but I'll just try not to press tab so it doesn't auto-complete it for us. Now, there are multiple ways you can do this. You can say that it's already suggesting new map because that's like the best way of doing it. But first, we look at, okay, if you want to just brute forces, just want to achieve the goal, right? Without thinking about the complexity or thinking about, oh, let's make it good, let's make it fast, thinking about scalability and things like that. Just want to brute force. What you'd most likely have to do is loop through it, right? You could use maybe array or reduce, or you just loop through script. It's often easier to just loop most times. So let's say we say we want to loop from the beginning, kind of like this. We want to start from the first number 2. And when we pick 2, we want to pick each of those other numbers one after the other, add them to 2, and see if it gives our target or not. If it doesn't give our target, we move to the next one, right? So we start with 2, we want to pick 11, add it to 2, see if it gives our target. Then we pick 7, we add it to 2, we see if it gives our target. And we keep going like that. So by the time we add 2 to 7, to give our target already. But what way can we make sure we are always moving through? Even though we pick the first item, we have to move through, we have to do a second loop through the array, right? That's the second, that's like already suggesting that second loop to me. And we have this second loop that is going to occur. And what we are doing now is we pick the first item, which is 2. And then for this second loop, you see that we are saying I plus 1, meaning the current index of I, because this now, I is going to start from 0. And at 0, it will loop through. When it is 0, this will be 1, right? And that 0 will loop through 1, 2, 3, right? 0, 1, 2, 3. 0 will loop through 1, 2, 3. And then when it comes to 1, 1 will loop through 2, 3, right? Because we've already compared 1 to 0 already, so we don't have to go to compare 1 to 0 again. We just go to 2 and 3. And then when we come to 3, 3 is just 3. At that point, there's nothing to compare it to anymore, right? And it just ends with there. So for this now, let's now say constant sum equals to, we want to pick the first index from I and the next index using J. We compare these two to each other, and then we see if sum equals to our target. That means index I and J, the sum of both of them is our target. Then we can just return that, right? And if you look through it like that, this will just break out of the loop. Now, if we want this should work fine. And let's say choose some numbers. And let's burn index.js. Oh yeah, I'm not logging it, so let's just console.log. And we have 0 and 2. That's 0, 1, then 2. 2 and 7 come together. 2. Now the thing is, if this array is very short now, right? So time does not really matter. If it was longer, like then it will take a little longer because now it is going to loop through all of these items. And this is what 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's like 10 items in the array. And it loops through the first one, picks the first one, loops 10 times. Then the second one goes, when it picks 11, it loops through all of this. It picks 3, it loops through all of this. It picks 55, it loops through all of this. And now let's even, this will kind of end fast because 1, 2 plus 7 are so close to each other, right? If it was something like this, it would have to go 1, add all of this, 11 add all of this, 3 add all of this, 5 add all of this, 24 add all of this, before it gets down to 2 and it ends it. So the larger it is, the more time it will take, which is really bad. And that's O n of squared, right? Because you are looping through it twice. It's like 2 loops. Now imagine like you have 1,000 items to loop through. That will take forever. And that's why if you now want to solve this, as I mentioned earlier, most time for most nested loops, you can use hashmap to cut it down from n squared to just n, right? Make it linear instead. So let's say choose some map. Right, and we have our numbers and our target. Now the first thing we do is create our map, right? Let's just call it thing, because we want to see I call this thing to signify the things that we've seen already, right? What number or what particular index have we found among the indexes that we can add together to get the value that we're looking for, which is 9, our target. Now we're still going to loop, but this time to be just one loop, right? It's just one loop. And this time we don't need to do a second loop. Instead, we're just going to create like a value that we'll call complement, which basically means what the other value is looking for, right? What we can add to it, or what the other value that adds to this current value will give our target, just as it's saying, right? Our target is this other value that we currently have, which will be 1 at this moment. If you subtract 1 from our target, that's 8. Now we are going to save that complement, right, that we've just seen. We try and check if our screen map has that complement already. If it has that complement, that means, oh, okay, this number already exists, and this other number that we're adding to it, it gives our target, and we just have our 2 indexes. I think if I write it will make more sense. So what I'm saying is this. This is what I'm saying. What we do first is we check if we have this complement in our item already. So for example, we're going to 111, right? When we are starting the first one, at index 0, our numbers 0 is 1 and our target is 9. That's 9 minus 1, which is 8. And 8 will not exist yet because at the beginning our map is empty, right? So we set 8 doesn't exist yet, and what we just do instead is we can return this as keeping this block, and we set this number, which is 1, to its index 0. We set 1 to the index 0, and then when it goes to the next one, 11, target minus 11. So that's like 9 minus 11, that's negative 2. It won't exist because we don't have that, and then we set that to 11 is 1, right? Then the next one, 3, and like that, and like that. By the time we get to 2, where are you? Okay, so 1,000 is, let me just see, 1 is 0, 11 is 1, 3 is 2, blah, blah. By the time we get to 2, which is index of 8, right? Now we have a value, that would be 9 minus 2, which is 7. At 9 minus 2, which is 7, here too, as we did the other ones, there's no 7 yet in the complement, because at this point, there's no 7 yet. In the complement, we have 1, we have 11, 3, 55, 24, 45 to 23, 1,000, and 2, right? We see that there's no 7, we save 2 there, and then 2 is now added. And the next one is 7. When we say 7, that's 9 minus 7, which is 2. The moment we get that, this time, the moment we look up the list of items in our map, we see that we have 2 already. So we know we have the other part of our target. We have the other side of our target. We had the other side of our target already, and now we know this part that is remaining, which is 7. And we know what the index of 7 is, which is what our I will be at that moment, right? And we can just return it like that, straight up. Because what we are saving as the value to each key is the index. The value is 2, I mean, the key is 2, and then the value is 8. This 8 is the index from the original list of array that we had, right? And then we have 7, 9. At that moment, once this comes, once it says it can return it straight up. And we'll see that here we are doing just one loop, unlike here where we are looping twice. And they both solve the question. They both solve it. Just one is much faster than one scales better than the other. Right? They will both give the same answer, but one scales better. The other difference between them is even though one is faster, the larger the numbers, the faster it will become. Like the larger the numbers, like okay, this is what I'm trying to say. Yeah, when the numbers get really large, is when you see the time difference. So for this small number right now, you don't really see the time difference between the two, right? Because at the end of the day, Java is very fast. It's going to run very fast. But when we have numbers approaching like a million records, then you see the time difference because it will take time to loop through it twice, unlike just looping through a million once, right? The other thing though is this brute force method where you are looping through it twice, it takes less space because in this one we are creating just two variables, I and J. We're not creating any other thing, right? So it takes very less space. Like no matter the number of records, we are only going to create two variables, I and J. So it doesn't take a lot of space. Unlike the sum map, which takes a lot of space, because the space it takes is relative to the amount of your record, right? As I mentioned, if you look at this now that I wrote here, this is a lot. And we have this key value pair, what, like 8 times already. And to get to the last one, which is 7, okay, it won't add to that last one because at that moment it returns. But we have the key value pair 8 times, which is very close to the original list of the array. So the space that map will take is relative to what you are trying to add into map, right? Your what do you call it? Your original list of values. I think one other one that we could use to show key value pairs if you are trying to check for I said key value pair where you can use hash map for. Another one is, let's say you're trying to trying to check if an array contains a duplicate, right? This is also a kind of popular coding interview. Like you'd have seen it in a lot of it's kind of popular among if you're looking at like junior or mid-level interviews, you see things like this a lot. Find duplicates, check if it contains duplicates. And I'll be honest, I think I've done before in different interviews. I remember when I did this in interview, I believe I used Arido videos in it, which is basically loop, right? The guy was cool with it, but it could be better. And you can use a Arido loop to find duplicates, right? So let me see what course is going to say. It's trying to use map. Now, if you want to find duplicates in numbers, you could use your array or what do you call it? Reduce, right? I think I used reduce. I can't really remember how I did it, but let's see if I can attempt it again using reduce. How much time? Oh, okay. Okay, I'll try and move faster. Let me just use map straight up, right? For this now, you want to you want to see if it has duplicates. Now, first off, let's try the two things. First one, let's first see if it has duplicates at all. Contains duplicates. Like, does this array contain duplicates or is just unique numbers, right? First thing we'll do is we create a set for this one because we just want to check if it exists, right? We don't need to use map. We just use set. And what set does is it just saves keys. So it could be something like 1, 2, exactly, something like this. This is what a set saves. Unlike map that says key value pair, it says just keys. And what we'll do for this one is we loop through it just as it's suggesting here. Exactly what it's suggesting, right? We loop through the numbers and what we check is we check if this is what we want to do. We want to look through the number and add each number, right? We want to convert this array to a set basically. So we are looking through the number and adding each number. But before you add the number, we want to first check if that number already exists or not. Because if it already exists, that means at this point we are looking at a duplicate of that number. That means it contains duplicates, right? And this should be contain duplicates. That means it contains duplicates. And then we can just say if you can find this, because as checks if a value exists, right? It returns a boolean. So if you can find the particular number that we're looking at right now in the set that we created, just break through the loop and returns true. And that's like really fast. This is also linear because it's just one pass through it. I mean, the larger the number, the longer to take, but it's just one pass. It's not looping through it multiple times. Unlike if you are using like for loop, where you'd have to loop multiple times because you have to compare each item to every other item to see if it exists again, right? Which makes things more difficult. And let's say let's say instead of just checking if it contains duplicates, you're trying to get the number of duplicates it contains. And for this now, instead of set, we'll use map because we're trying to know, we want to save a key value pair this time, right? And for this, we say, if this is this, we can just, instead of returning, we set the number and sorry. Sorry, 1 second, please. So as I was saying, instead of just setting the number for this one, we want to set the number of times that that number exists, right? We want to say if, okay, I think I'm good now. Yeah. So if it doesn't have the number yet, add it, right? Add it to our map and give it an initial value, 1. Let us return same. And if it had it already, right? If it has it already, we just do this. So if it doesn't have it yet, we set the number and we give it an initial value, right? It starts at 1. But if it has it already, we are going to just increase it. And this way we'll be able to get the number of times that a duplicate exists. So let's just see if this actually works. I don't need this true anymore. So the first one confirms that it has duplicates, and this second one is trying to see number of time each number exists. And it looks like the whole exists twice because it's just repetition of 1 to 10 twice. So that works. So to confirm that it really works, reduce 1 and see again. I think 3 should be 1 now. Yeah, 3 is 1. So this is like a much easier way of doing it instead of having to look through it twice. Apart from the fact that this takes like less time to write, I know it's very scalable. So in an interview, I'd say try and do it both ways. Do the brute force method first, and then try and explain why you are trying to cut it down to use this other method using hash map or set. Then Then we have these anagrams. You could solve anagrams that way too, right? Let's just go through it here. Where it says you have this array of different numbers, right? So different words, and you want to group them based on anagrams. The ones that they share the same letters, different words having the same letters, like it and T is still the same 3 letters, and you want to group them properly. Using map, you can easily do that. If you look at this code now, what it does is it's looping through the array. We have our map that we create at first, right? Then we loop through the array, right? Then each word, we want to split the word, but when you say string dot split, with an empty string like this, what it means is it's going to pick each letter in that string or in that word. It splits it into each letter. Then we sort it, just sort it in alphabetical order, and we had it. Meaning each of those three letters will all look the same, right? So A, A, T, T, A, and Et will all become A, E, T, A, E, T, A, E, T. And since they are all the same, you put them together. That means they're anagrams of each other, right? So you can group them together. And what we just do here is we check if it has that key, yes. If it has AET key yet. If it doesn't have AET key, we create the AET key and we give it an empty array. Then we push that particular word, which will be the first one is it. We push it into the AET key. And we do that. But when it sees T, it will be the same thing. We push it into that family array. Then for tan, which will be ANT, is that ANT or yeah, I think it should be ANT here. Tan, which should be ANT, is going to create a new key for that again and push tan into it. Like that, it will be able to sort out the table for you to create this array from it, which is pretty cool. Going to 2 pointers, and 2 pointers, as I mentioned earlier, is basically you have you pick 2 points in your array and you are looping through it, but you are going through things from two different directions. Like you can start from the beginning and the end. That's why it's called 2 pointers. You start from two different points and then you look through them. And if you think about it, you feel like, okay, I can probably use 2 pointers to solve the sum problems, right? Because I can pick the first item and the last item, see if they equal each other, and then just move forward from the back, like move the first item forward. So I mean, left is 0 at first, then I make left 1, then the last one, which is right, which is the last item, I move it back a little. You can just do array.length minus 2, right? Which moves it back a little more. And then you compare those two again if it kills the target. But the big difference in this is it won't work properly if they are not, if the array is not sorted already. Because the only way you know that you have to move it, if you have to move the left forward or the right backward, is if the number you are getting is higher than the number that you want to get. So for example, if we go back to this one, right, which is 1, 11, 3, blah, 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 like that. I'm going to use 2 pointers. 2 pointers, we pick 1 and 15 and add them together at first, right? That means we're going to find a way to say 1 plus 15. When you had 1 plus 15, the answer is 16, which is less than which is much greater than our target, right? Normally, you want to go for a smaller number on both sides. 15 is very large. You want to go for a smaller number on the other side. You say 1 plus 7. But the thing is, at this point, you can't always know if you are getting a smaller number when you go to that next index, because it is not sorted in alphabetical order. So in incremental order, right? You have to first sort it. You'd have to first sort it. If you want to use 2 pointers, you'd have to first sort it. And then you can now properly add it and say 1 plus 1000. Oh, okay, that's still too much. You want to reduce it. 1 plus 223. And things like that. And you keep reducing it until you get the two pairs that gives your particular value. And at this point where you get the two pairs, you still can't solve the question because you are supposed to give the index of those two pairs. But you've already sorted it, you don't know the correct index anymore. So instead of that, it's just better to just use map. So when I think about it, okay, when can I now use pointer then? If I can use map if I can use it for this particular one. You can use pointers for like palindrome, right? You want to see if a particular word gives the same thing from the front and from the back, right? And there's this particular phrase that they like to use a lot in a lot of them. Instead of giving you just a word, there's a phrase. I'm just going to show the code instead. Where are you? Yeah. So we have this phrase: a man, a plan, a canal, and Panama, right? If you look at it from the back, it gives the same thing. If you ignore the special characters like space and comma and this colon, it gives the same thing. A man, right? A plan, a canal, and Panama. It gives the same thing again. And how would you solve that? Using the 2 pointers to make it easy for you, right? You have the first point, which is your left, which will be the first index, and then the other point will be the end of your array. And you're going to move from front and back. And what you do is make sure you are moving both of them at the same time. right? You also have to make sure you are skipping any special character, which is the essence of this regex that is here. What this does is, let me log this so you see what this before and after is like. You see, before at the beginning, before for left and right, we have AA, right? Then none of those two items, none of those two characters are special characters. So this while loop, both while loops will get skipped, and it's going to compare them to each other. If they are not the same, it's going to return false, right? And else it's going to move on to the next one. Because they're the same, so it's not going to return false. It's going to move on to the next one. And next one is M from this side, but from this other side, it's space, which is a special character. So because of that, for the left side, this particular while loop will run, because this regex is trying to say, okay, is there the particular character that is there? It has to be either A to Z or 0 to 9, right? This clear should not be here. A to Z or 0 to 9. And if it's not that, it's going to shift one more time, right? Move one more time in the particular string and pick the next item, which is M, not space this time, M. And now it's going to compare M and M. They are the same thing again, and it's going to skip this and move on to the next items again, which should be A and A. And it goes like that through all of it. At the end of the day, it's going to give a palindrome because at each point, the characters from left and right are the same. If I had something else here and say G, here is going to break and give false because it's not a palindrome anymore. At some point, we have G from one side and C from the other side. And it just breaks it here and returns false. Now, that's what two pointers are and how you use them. And other ways to use two pointers, we also have like sometimes they're going, instead of going from opposite direction, you can be going from the same direction, right? Where one is moving faster than the other. Could be used for checking for duplicates too. Unlike the map that we just use, map and set, you could also use two pointers to check for duplicates this way. I like group duplicates together. It's a little crazier, but map and set is often easier than most things. Map and set is like one of the easiest way to work through anything as tables, right? Then next one is the sliding windows. And I mentioned the sliding windows earlier where I said you are trying to, you have a window and then it's kind of like literal sliding window because you have the beginning and the end, and it can either be like a fixed beginning and end. I'm trying to see the highest number of items I can fix in that fixed beginning and end, or you are trying to adjust the beginning and end to fit a particular number. So let me use this. Um, I have two examples that I'll use to just explain them, right? First one is length of longest substring. Here you're trying to see what is the highest substring, the substring, like non-repeating substring with the longest length, right? That it doesn't repeat itself. For this particular one, ABC, ABC, BB, right? What's the longest point at which the letters don't repeat themselves? It's ABC, right? Because we look at this ABC, nothing is repeating. At point when you get to A, it's repeating already, so it's not valid anymore, right? B, C, A, not repeating. When you get to B, it's repeating already. So 3 is still the highest length that we've seen. BCB, B is repeating. CBB, C is repeating. So it's 3. And how would you achieve that? I mean, looking at it, you can say it, but how would you achieve it when you want to write the code, right? For this is where you use the sliding window, and we create a set for it at the beginning. Let me just try and write it out instead of just reading the code, right? Try and write it, try through the thought process and see how it works. So let's see. Right. First thing we want to do is create a set because we want to have something that we are comparing it to. Somewhere we are storing each letter that we are saying. We want to have somewhere we are storing each letter so that we can compare it to that and see if we have to remove a letter or add a letter to it, basically. Right. That's why we have this character set. Then we have our left and right because we are trying to create a window. Window has beginning and end, right? Kind of like 2 pointers. But like 2 pointers where the beginning and end is always shrinking. For window, it can either shrink or expand or be constant. That's the big difference between both of them. And so we create our beginning and our end, left and right, right? And this one too, we are starting sorry, left, our beginning and our hand will always move, right? Because for that our hand will start from the big from close to the beginning too. No, we'll create our hand later on. And the other thing that I created the result. What result is we are trying to find we want to find a way to store what the highest window size that we've currently seen is, right? Because as we go through it, the window size will change. In this one that I mentioned earlier, right? A, B, C, B, A, B, C, B. We have A, B, C as the window size. The moment we see A again, we know something is wrong somewhere, then we have to remove this first A. Then the window size becomes this 3 again. And then we see B again, and we have to remove this first B. The window size becomes this 3 again that we highlight. Then we see C again, and it keeps shifting like that. At some point, the window size will become small, but that's still not the largest window size because the question is to find the longest one, right? We want to find the largest window size. So if we don't have a way of storing the largest that we've currently seen, we're going to lose track of it. That's why we have result, which starts at 0. Now let's say for this, we want to loop through it, right? We loop through the array from the beginning. We're starting from, let me just copy this boy ABCB so we can be looking at it here. And looking at this, what's going to happen is we start from the beginning, right? Let's skip this first. We start from beginning and we want to add each item on our right hand side. We want to add each item to the set. But when we are adding each item to the set, we also want to make sure that we are not adding an item that already exists. If it already exists, we have to find a way to remove it, right? And that we can't just go and remove just that item. We have to, because it's a window, we don't want to put a hole in the middle. And what I mean is this: we find A, then we find B, then we find C, and then when we see another B, so when we see another A, if we say we want to just go and remove this A here, like we want to find the other A that already exists and remove it, it still looks good, right? Because once we remove this first A, it becomes BCA, right? And then we go on, the next thing we see is another B. And if we say we want to find and remove this first B again, it becomes CAB, right? Which is cool still. And then we find C again. We remove the same C, the first C, we find out remove the first C, and then we have ABC again. But at this point, things will now spoil where the next letter is B. If we want to find out remove the next B, we are going into the middle of the window and things get messed up because we don't want to break our window. We want the window to remain fixed. Like we want our window to remain fixed without putting a hole in between it. So instead of finding that letter to remove, what we'll be doing is we'll be pushing out letters from the beginning until there's no repeating letter anymore. And what I mean by that is this. That is there, right? This while loop, what it does is it confirms because for set, when you say dot as, you're confirming that that set has a value or doesn't have the value. So we want to check if it has S, right? And remember, when we say, I'm assuming people know this, I've not really mentioned it, but I feel like I should. For these different cases now, the first, right? When we say S left, it basically means S of 0. At the beginning, it means S of 0. And S is the string, right? 0 is the first item in the string. That's A. And then when we say S of right, that's like the next item because we've said plus plus. It has increased it by 1. And that is B. So at the first time it runs through, it adds A first, right? A does not already exist in the character set. So it's going to skip this while loop and add it to the character set, right? And then it's going to say mathmax. Now, this mathmax, you'll be wondering, why are we using it like this, right? Because math.max basically means pick the highest value between these two values, the one on the left and the one on the right. This one on the right is basically we're trying to say what is the size of the window, which is the right minus the left. It's like we're trying to see, like when someone asks you difference between January and June, the number of months between January and June. And most times you won't just say June minus January, like June is the 6th month, January is the 1st month. You won't just say 6 minus 1 and 5 and say, oh, there are 5 months. From January to June is 5 months. No, you want to count the full months, right? When you count, most times you start from January up to June, like January, February, March up to June, which is 6, which is basically the left minus the right or the right minus the left, then plus 1 to account for that first item that you're accounting for. And that's why we have the plus 1 here. This now gives, this is the current window size and what window size that we want to achieve, which is result. Check for what is the maximum value. It's 0 at first, and then this is 1. Result becomes 1. And when we look through it like that, when we go to the next one, just as I was saying here. But this time, when we go to the next one, B, right? B does not exist yet. This will continue like that, and it adds B to it. I mean, it skips this loop and it adds B to the set and goes on to C. C does not exist yet. It skips this loop and adds C to this set. At this point, our result will be 3 because right minus left, which should be 0, 1, 2, 2 minus 0, because left has not increased already, right? 2 minus 0, it will be 2 rather. Then when it gets to A here at this point, it now says, oh, and when it gets to this A and it checks, it looks up the character set, it's going to find that, oh, we have A already here. And what it does here is it pushes out the item that is currently on left, which is the first item currently, right? Because left is 0. So it pushes out this item from our set, right? And increases the position of the set. It's basically shifting the window because now we've gone through this first 3 and we're on this first one. When we go to the fourth one, which is what I'm indicating here, we realize, oh, this thing is duplicating already. This substring is duplicating already, and we don't want any duplicate in the substring. We push out the first item, right, which is the position of 0 on our left, right? Position 0 on our main string. We push it out from our character set because at this point, our character set would be like this. A, B, C. Now we want to find C from it, which is using that. So we want to find A from it, which is the current index of 0 from our string, and we push it out. Then we increase left by 1, moving our window forward a little because our right window is going to move too. We increase left by 1, moving our window forward, and we save what the right currently is, which is A. And our window, what is our window, or what is in our subset, in our character set rather, becomes B, C, A. And when we go to the next one, right, because this is a loop, and after it runs, the next loop, right, increases by 1, and it becomes what? 0, 1, 2, becomes 3. It finds, 4 rather. It finds another B, right? And this time when it finds a B and this character set runs again, it's going to see that B that already exists. And because it already exists, this loop is going to run again. It's going to delete S left, which is, and left at this point is 1 because we had increased it by 1. And this is 0, 1. B is going to delete the B in our set again. And this set becomes CA. And when this particular line runs, it adds the item on the right, which is B. Since right is currently 4, 0, 1, 2, 3, 4, it adds B to it, and we have cap again. Again, our length is 3 again, right? Our length is 3 again, and we save that in our result, and we keep going like that until we get to the end. And at the end of it all, it gets to the last BB, right? So here now it says ABC again, and the next one is B, and it removes A and it becomes BCB. It would become BCB when it removes A, but the problem is B still exists, right? Meaning it doesn't become BCB actually, because when it removes the first A at this point here, when it removes the A, this while loop check, this condition will run again and it tries to see, does our character set already contain B? So this is what I'm saying. At first, it's ABC, which is this particular point here. It is ABC. And what is coming to join it is B. Because B is coming to join it, it removes what the current location, the first item there, right, which is A. It removes that item. And then we have B and C. But when it checks again, B still exists. So it remove the next item again. We remove that B and we have just C. And now that we don't have a duplicate, it adds the B to it. Now we have C and B. And it moves to the next one again, and which is another B, the final B. Right. Now we have 3B and we are adding the final B to it. And this time it's going to remove both of them because first it removed the first item, which is C. It sees that, oh, there's still a B, then it removes the last item, which is B. And at the end, we have just one B. And the window size at this point is just one. But we had already seen a window size of 3 earlier, which is we saw 3 here, we saw 3 here, we saw 3 here, and we saw 3 here, which we've saved using result. That way we're able to now find, okay, the maximum length of substrings that we can find for this particular string is 3, right? That's our window size. We have a fixed window size in this particular one. And that's for like fixed window size because we already know we have a fixed one that we are trying to work with. Then there's also like variable size, right? Oh, rather, sorry, that's variable size because we are increasing and reducing it. Like we are expanding it and we are shrinking it. So we expand at some points, then we shrink again, then we expand and we shrink again. But what if we have a fixed size? We have a number that we are working towards already, and we just want to find the highest number of things that can fit in that number, right? For example, if this one we already had a number of 3, right, and we are just trying to find the highest number of things that can fit in it, it will be a totally different scenario. We won't be shrinking one and then expanding the other. If we look at this one now, let's say we are trying to find some average, right? Not some average. Let's say we are trying to find the maximum sum instead. We want to find the maximum sum of items that that come like the maximum sum that we can find from this array. And what I mean by maximum sum is this: we want to find the maximum sum of 4 items, right? Because the constant is k here. So what are the 4 items that when we add them together in this array, they give us the maximum number, the maximum amount. So meaning we say 1 plus 12 plus 5 plus 6. Is that the highest? If not, then we have to add another 4 like that until we get it. And they have to be chronological, like they have to follow each other in their way. You can't say 12 plus 50. Because if we are just trying to pick the highest 4, that one is very simple. You just sort it from you sort it in decreasing order and you pick the first 4. That way you have the highest 4. But that's not what he's trying to do. What he's trying to do is find the 4 that follow each other that give the highest number. And what we do there is this is how it just tries to do it, right? Using the sliding window still, right? First thing you do is pick those first 4 items and add them to each other. That's what this one line loop does, right? It says starting from 0, if I is less than k, which is 4, right? Increase I by 1 and pick. So what Windows Sum now does is it picks each item on each index, right? So this is going to pick 1 plus 2 plus, 1, 12, 5, and 6, add them to each other at 24. Now, at this point, these are maximum sum that we have, no problem. Then we'll now try and compare the other ones. And what we do here, just as this says, we add the right and we drop the left, meaning this is the window at first, right? Then we want to move to this, meaning we want to drop this first item and add one extra item at the end. From this, we want to move to 12 plus 5 plus 6 plus 50, which is going to be 73. And then we move to the next one again, which will be 5 plus 6 plus 50 plus 3. And at that point it ends, which is going to be 64. And that's basically what this is trying to do. And what the way it does it is it increases the right hand side. It adds one extra item to the right hand side and drops one extra item from the left hand side. Now the main question is, how does you know where the left hand side is? Because the loop is always shifting, right? If you look at this, the loop is starting from K as the first item, which is 0, 1, 2. So it's starting at 4, right? 0, 1, 2, 3, 4. It's starting at this, and then it adds the next item, which is 50, right? Because we are increasing by 1. It has the next item, which is 50, and drops the previous item, which is I minus K, and 4 minus 4, 0, right? So it drops the item on index 0. And as we know already in JavaScript, when you say plus equals to, that means that add this new item to the current value. Minus equals to is subtract this new item from the previous value. And when it adds and drops, so at the beginning, if you look at this, maxsum is going to just pick what the maximum number is. At the beginning, the maximum number is 24. When this shift happens the first time, the window sum becomes 73. Then it compares 24 and 73. 73 is higher, so it picks that as the maximum number. Then when it shifts again the next time, the next number is 64. To compare 64 and 73, 73 is higher. It keeps 73 as the maximum sum. And at that point, it has looped through the whole array, and it just returns what the maximum sum is, which is 73. With these two, of course, you can try and use for loop, like nested loops or array or reduce to try and do it, but that will take more time compared to just looping through it once, right? And that's the essence of trying to understand how sliding windows, how hash map and things like that, how they all work, because it makes it easier for you to do things like that. So at the beginning, when I did the first one, which is I think the one that took the longest time, I tried to go through the two different scenarios, which is how you should try and do in most interviews, right? Let's look at it. If there's any edge case, any question that you need to ask relating to the particular algorithm or the particular challenge that is given to you, ask it. It shows that you understand it, right? Because a lot of times they'll give you a challenge where there are some obvious things, there's some obvious information that you need, but they won't mention it on purpose. They want to see if you're going to ask, right? It also shows that you're confident if you're able to ask those questions. You ask them, then you get the correct answers. Then first find the simplest approach, the easiest way to do it. Oh, just going to most times you can just attempt to do something with for loop, right? Also, when you're doing things like this too, you also have to take into account how much time you have, right? Because if you have a lot of time, you might waste too much time with the brute force. If you have a lot of time and you know you could do it in a better way, right? A good pattern, maybe like hash map or something, just attempt that straight up. And if you have enough time, you can now explain why you use the hash map, the other way that you could have done, which is like the brute force. What could have happened if you use brute force method, like the nested loop method for that to sum? What would have happened if you use a nested loop method? Why you choose to use hash map instead, and how much better that is, right? How you can easily scale it, things like that. Then communication, just as I mentioned, which is basically what I mentioned earlier, right? You communicate, you try and explain why you're doing it, why you did this, what's the implication of doing what you did, right? What are the trade-offs, right? Is this faster? Does it take more space and things like that to try and explain all of that? And when you want to practice, and if you remember this that I showed earlier, where are you? Yeah, the foundation, which is what we focused on today, right? That's always the best thing to start with. Don't just pick a LeetCode challenge at random and then attempt to do it. Because I mean, of course, if you're not able to solve it, you can check the answer easily, right? And try and read it and understand it. Because you understand the basics of coding, like A plus A is B and things like that. You understand how constants and variables and things like that work. You'll probably be able to understand it a little. But it might still be difficult to apply it to when you see a similar challenge that's not the exact same thing. You might not be able to relate easily because you didn't fully understand it. But when you start from the foundation and understand the foundation properly, the fundamentals, it makes it easier to scale up. So I would say if you need a roadmap, this is the best roadmap, right? Start with the fundamentals, like to some palindrome, and these are things that you can do easily with your hash map and your 2 pointers and things like that. Start with the fundamentals, then go into core patterns, right? Which are at that point start getting crazier, right? Longest consecutive consequence and things like that, like permutation, threesome, unlike twosome that was before. Then sliding window, and then you can now start thinking about trees and binary search where things get properly crazy. And a lot of times, as I mentioned before, a lot of those things you don't really use when you start, like when you get in the company and you're writing code in there. The chance of you having to use binary search is very slim. Right? Most of the things you do are array and hash map. IS maybe hash map, right? Because I have to use hash map a few times. IS you might have to use hash map. But binary sort, in most jobs, you most likely won't have to worry about having to write things like that. And now for resources, these are some resources that I'm going to share. I think I'm going to drop all of this in the chat so you could check them out. If you are someone like me that prefers videos, right? This is a good channel to use, right? LeetCode. You can just search for LeetCode on YouTube. It's quite good. It explains things properly and it will help you to level up a lot. Let me just drop that in the chat. Oh yeah, sorry, I was not even checking the chat things. So LeetCode on YouTube, very very good, right? And you can also check his website, leetcode.io, right? And it contains like proper roadmap and explains a lot of things. When LeetCode is very popular, so I'm sure a lot of people here already know what LeetCode is. You'll see a lot of challenges there that you can work with. And the good thing about LeetCode is you see the solutions and you can also see I think you can also see explanation of the solution. Then one other one that really explains big O is the cheat sheet. Like someone created this website is very good. I think this was created like almost 20 years ago now. Yeah, it was created and it contains a lot of cheat sheets relating to big O. This should be big, not bid. I can't edit. And this is basically him. And you see some comments from 13 years ago. Like that's how old it is. Right. It's pretty cool. Explains the big O complexity. And then we have akanon.com. I think I can also share the slides with Chizurum and you can share it with the community if anyone needs it. Slides have gone longer than the time I was thinking of self. Is there any other
Okay.
question?
Yeah, thank you so much, Tao. Maybe we can take just one or two if there's a question. Does anybody have any question? Anyone? Anyone? Okay. So maybe Taufeeq, one other thing is you can share the slides with me and then I can share it with everybody after the session. But thank you so much, everyone. I wanted to talk about the hackathon, but we're way past our usual time. And before I even say what I want to say, this was really, really, really insightful. Taofi, thank you for spending time with us. Thank you for sharing. And thank you for all the resources that you dropped and the ones that you still share with me. I'm really grateful. So I'm just going to put some relevant links in the chat for anybody who is interested. So the first is to API Marketplace. So you can use the test to see how it works. And then the link to our community if you'd love to join our community. And then a hackathon. So we're hosting a hackathon this month. And you can get to know about registration, submission details, and all of that in the chat. I think my camera is glitching, so I'll just put it off. But that's it for today. And don't worry, the recording will be up on YouTube. I'll email the link to everybody on or before Monday. But thank you so much, everyone. And thank you, Taofeeq. This has been really good. And we're definitely going to have you back again for another session. Thank you for giving your time, for really spending time to, not just talk through it, but actually show how it works. Thank you so much. We're grateful. And you can always connect with Taofeeq on LinkedIn. His name is Taofeeq Oluderu. I hope I pronounced it well on LinkedIn. So if you have further questions after this, you can also connect and ask him, or if you prefer to share it with me, that's also good. I should have put a link to Taofiq's email. Yeah, Oluderu. Yeah, thank you. Taofiq's LinkedIn rather. But I'll actually even do that before the call ends. Or if you have questions that you prefer to pass on to me so that I can share with Taofiq, that would be really great. But thank you so much, everybody, for attending today's session, and we'll see you at the next year. Thank you, Tao, for sharing that. All right, everyone. Do we want to say thank you to Taofeeq? Do we want to type it in the chats or something? No, everybody is muted, so we can use the chats just before we go. Do we want to do that? Yes, I'm actually going to go first. All right. Bye, everybody. See you at the next. Bye, bye, bye.
You're
Hey,
welcome. Bye, everyone.
yeah. Enjoy your weekend.
Yeah, you too.
All right.